Perfect. Yeah, so welcome everyone. So the topic today is the state of observability in .NET and tracing .NET applications in production. So that's me. My name is Jaeger. That's the real name. No one can pronounce that. So in German, I go by Jaeger. That's like in Austria, people can pronounce that. But Americans still can't pronounce that. So usually in English, I go by Greg. Choose whichever you can pronounce. I'm fine with whatever. So I have a website. You can look it up. I'm also on Twitter. So if you have like any question to the presentation, any question to the demos, any question to whatever regarding observability, I'm available there. So I work at Elastic. Elastic is basically a distributed company. And I'm responsible for building observability tools for .NET. Who uses Elasticsearch? Any Elasticsearch user? 1, 2, 3. Okay. Who knows what that is? Many people. Okay, that's good. Okay, so Elastic is basically the company behind that. Elastic is like a data storage, and basically what I do is that we build observability tools based on Elasticsearch. So we store the data in Elasticsearch. Everything that I do is actually open source. So code that I write, it's on GitHub, it's Apache license. You can do whatever you want with that. And I'm a co-organizer of a thing called .NET Stammtisch, which is a similar event to this one in Linz. So we are basically a .NET meetup, very similar to this one, in another city. So I was born in Hungary, so that's the reason for the funny name. But I live in Linz. I moved there I think 7 or 8 years ago. Another organizational stuff is that I try to record this stuff. So that iPad is recording this area. So if you don't want to end up on the internet, you avoid this area during the talk. And if everything goes well, then you can find this talk at my YouTube. That's the important slide that you could maybe like take a picture or whatever. So there is a link for all the code samples and all the slides and basically everything. That shows that points to a GitHub repository. So just go there and then you don't need to take notes. Of course you can, but you don't need. Okay, so what's the agenda for today? So I'm going to start talking about like what is observability, why is this important, and then I'm going to show you a couple of tools. I'm going to show you application insights. I'm going to show you Elastic APM. That's the stuff that I work on, and then I will also talk about Jaeger. Then we will talk about how to trace stuff in your code base manually. Then we will talk a little bit about distributed tracing, and then we will talk about OpenTelemetry, and then we will dive deep into diagnostic source and activity. So we will like basically start on the surface, like what is this observability, how can you use it, and then we dive deeper, how can you extend that, and then at the end of the presentation we will really dive deep into the .NET framework and see how you can basically automatically capture tracing information from the framework. So the goal here is to give you an overview about observability. Like I'm going to talk about like what standards there are, what open source libraries there are, and if you say, okay, this is interesting, we wanna use it for our system, then you will be able to basically just pick a tool and then decide whether it's useful for you or not. Now, it is not my goal here to show you a single product. So this is like not a product overview, and this is not a like tutorial style talk about a single product. So I'm going to show you a couple of products like Elastic APM, application insights, but this is not only about application insights. Like my goal, like I said, is to give you the big picture and like what feature is there in a specific product. I think that's really not relevant because it changes all the time. So that's not my goal here. Okay, so I prepared a very small sample application, and we are going to build observability for this small sample application. Let's talk about what this is. So this is an ASP.NET Core application, And the architecture is the following. There is a browser, there is a .NET Core front end, that's basically one .NET Core process. There is a service called fixer.io, which basically can give you currency information. So what we do here is that we take a number in euro and we exchange it to US dollar. We basically show the value of it in US dollar. And for this, we do an HTTP request to this fixer.io service. And then there is another service which talks to a SQL Server database, which runs locally on my machine. That's the architecture, super simple. Nothing fancy there. So let's just take a quick look at this application. Whoops. Let me close everything and start with one. Okay, so this is the demo application. It basically has two tiers. There is a front end. By the way, who knows ASP.NET Core? Hope everyone. Okay, who brought a web application with .NET already? Almost everyone. Okay, so let's look at this. There is one controller. Is it big enough? Can you see it? So what we do here is the following. We just have another service running locally. We do an HTTP request there. We read the response as a string. We parse it to a long value, and then we go to this data.fixer.io service. That's another HTTP call, and then we basically that basically gives me the euro-dollar exchange rate, and then we parse it into a double, and then we show the value in US dollar. Basically, that's it. Let me show you how this looks. If I start the application. So we go to localhost 5000, and it basically says there is 10 million euro is that much in US dollar. That's the application. I told you that there is another service that we made this call to this localhost 5001. That's another service that talks to a database. Let's take a look at that one. What it does is that, first of all, it generates a random number, then it does a little bit of a logging, then if the random number is 0, then we calculate a prime number, which is fairly high, so this will burn a little bit of a CPU. It makes no sense in this application, but something should happen. If the random number is 1, we throw an exception, and otherwise we just read the value from a database. The database is here, there is a single value there, that's all it does. Okay, so that's the sample application. Does this make sense so far? Very simple. Most of the applications do something similar, but more of this and more useful. But that's basically it. Okay, so this is what we want to observe. So we will build observability for this. Okay, so let's talk about what is observability at all, because I already talked a lot, but what is it? Okay, so a system is observable when you can ask arbitrary questions about it and receive meaningful answers without having to write new code or a command line tool. So it basically lets you discover unknown unknowns and debug in production. So what does that mean? Let's say you go into the office and the first question is, does our application work? Are there any exceptions there? Are the users happy? And there is one way, which is that you just wait and the users call you. But the other way is to have a tool and then have an option to answer this question. If you know that, okay, users are not happy because the application doesn't work, and the next question is, okay, what's the problem, right? And the observability basically gives you the answer for that. So it can tell you, okay, there is an HTTP 500 that the user receives, and it tells you, okay, what exactly happened. People often talk about the three pillars of observability, which is basically logs, metrics, and traces. These are like the three important stuff that you can use in order to build observability for your system. And then there are other people. For example, she's the founder of a company in this space, and she says, like, no, there are no three pillars of observability. It's basically just marketing bullshit, and it's not good to have this approach, like having traces, metrics, and logs. And she basically goes on in this tweet, and she says that the point is that you need to have these three things in a single tool. I personally doesn't really care whether it's called pillar or not or whatever. What I want is basically a single tool that shows you logs, metrics, and traces for your application in a single place. That's this is all about. Okay, so let's dive deeper. Observability, we want to have these answers. Is everything okay with your application? If not, what goes wrong? And let's do the next sample. So for this application that I demoed you, I configured application insights, and basically that's what we are going to look at. Does anyone know what application insights is? Okay.
Is it similar to tick stack?
What's tick stack? I don't know that.
Okay.
Sorry?
Alternative state.
Yeah. Okay, so let's take a look. I don't know that product. What is that?
It's telegraph, influx table, chronograph, and capacitor.
Ah, okay.
Together, it's tick stack.
Ah, okay. Never heard of that.
Okay.
So, Application Insights is basically an observability product from Microsoft. Let me close this. So I'm not going to generate more requests on this application. I already generated a couple of requests. So let me dive back. So if you want to configure Application Insights for this given application, all you need to do is the following. In the front end, basically you add the NuGet package, which is Microsoft.applicationinsights.asp.NET Core. There is a NuGet package for basically everything. So if you don't use ASP.NET Core but ASP.NET Classic, there is also stuff for that. So you add something to your package, and then you write a single line of code. You just write services.add-application-insights telemetry. So with that, you will have traces and metrics from your application. I also wanted to configure logs for this application, so I did another thing, which is in the main method, I added, I called .configure logging, and then just added application insight logging here. So basically, I did these two things. That's it. Now let's see what is captured for this application. If you look at,
I have a question.
Yeah.
Is the application insights only for Azure?
Yeah. So
if I write an application that I might not deploy to Azure, I cannot use application.
Yeah. So the thing is application insights only for Azure? No. So the application insights backend runs in Azure. The UI is in Azure, and the stuff that takes your data is in Azure. But the application can run everywhere. And in this case, the application was running on my machine. So basically, you need an Azure account in order to have the server side that takes the data and the UI, but the application can run everywhere. And it doesn't have to be a .NET application. It can be Node.js, Java, whatever. Okay. So if you just did what I showed you in the source code, basically you will immediately see failures. Like you see how many failures happened in the application. You see the response time, so we know the response time. There is no load in the application. So in a real world application where you have real users, obviously you will see a little bit more here. And then so you see a whole bunch of metrics. You can also dive a little bit deeper. There is this performance stuff here. And you basically, what you see here is basically all the HTTP requests. So we executed the request to this home/index. And we can even dive deeper. So we see that there are 13 samples for that. Okay, let's click on that. this is a request. We know that the response code was HTTP 200. So for this given request, we know that it returned without an error. And if I click on that, what we see here is that there is this end-to-end transaction. So basically, what we see here is exactly what happened during that request. We see that it was a request to the home/index, and then it went into another host. This is running on localhost 5001. It triggered this endpoint, this /get value. So if we go back to the front end in the control end, that's the web request that we see there. You see, that's the same URL. I'm not lying. And we see all the database calls. Not only that, we see that the database instance, but we also see the database command itself. So it says select one, and then this is entity framework call. So I'm not writing it manually. That's generated by entity framework. And we also see the call to this service that gives me the exchange rate. And we also know that it returned an HTTP 200. So I got the real stuff. Okay, so previously I ranted you about having traces, logs, and metrics in a single application, and actually there is logging in this application. So when I went through the code, I showed you that in the service we have a couple of logs. So I do here generated random number. I print that. I print the value that we read from the database. That's the entity framework code. And what I also print on the front end, I also log the exchange rate that we received. Okay? So what you can do with the application insights, I click to this view all telemetry, and what I see here is everything for this request. And look what we see here. We see here generated random number is 0. We see that. We see the Euro USA exchange rate. That's basically the log. So what I get here is all my logs just for this one request. Okay? So that's when I talked about having logs and metrics correlated. It's super awesome to have logs for just one request, and everything else is not there. Does this make sense so far? This is kind of powerful.
Can you then just search for the log entries?
You can search for the log entries, but what do you mean by that? So if you would have your logs in another place?
No. You have the logging inside of here. You configured it so that every log that you do in the .NET application goes to the Azure portal.
Yeah.
Can you, and then you have multiple basically calls to this. Can you then filter out just those?
Yeah, so you can search only for that log line, and from the log line you can also go to the trace. That's possible. Yeah. Okay, so once terminology stuff. So application insights is strange. They call a log a trace. Totally confusing. But you could basically go from traces. No, there is no trace. Okay, let me continue. There is a okay. Let's dive into that part. So there is a stuff called the logs. So what I showed you is basically the UI itself, but you can also have access to the raw data. So what you can write is traces where I think the message contains euro, and that will show. So here I have a language, and the application insights give me data gives me access to the raw data, and I can basically search for all. They call it traces. Totally annoying. It's basically logs. You can search for all logs that have this string in itself. So yeah, you can also search for the logs, search for whatever you want. There is one thing I also want to show here is the failure stuff, which is So obviously, like what I showed you was a call where everything was fine. Right? If it's HTTP 200, you don't really care because everything is fine. But what you also can is just look at the failures. This basically tells me all the calls where something went wrong. Let's look at one of those, and we immediately know that the response code is HTTP 500. Again, we see an end-to-end transaction. We see all our logs. So for example, I logged you the random number, and it says generated random number is 1. That's where it is. And based on that, we could look into the source code, and we said that if the generated random number is 1, then we throw an exception. There we go. So the generated random number was 1, and that's where we throw the exception. Okay, I'm lost in my code, but anything, no, there we go. Okay, so that's where we throw an exception, and then we load the. Previously, we already loaded the random number. So these are things that we can figure out. Obviously, this is a very small application, so who cares? But if it's big, then this is really, really helpful. And then also let me just show you another thing. So there is an exception here, and what we see here is that this returned with HTTP 500, but we can find the exception that caused the whole thing. So we see the exception message here first of all, and what we also see is a call stack for it, and we know exactly that this happened in the DB service control as volume control as. So there were multiple exceptions in both tiers, but we can figure out what caused this, like what was the original exception across multiple tiers. So that's about application insights. There is also another, so application insights is basically one product, and the other product I would like to show you is Elastic APM. That's the one that I personally work on, and it's also very similar. Like the idea is basically the same. You have a view, and you have different services. So it automatically discovered that there are two services here. There is a front end and there is a back end. The front end is this is the front end. These are the HTTP calls that that went to this application. What you see here, like we show a different view. So what you see here is these are so-called spans, and this is like a kind of industry standard word, which is like worth to remember. So a span in these tracing systems is typically like one of these boxes, and it's basically just any arbitrary operation. So this span says that there was a GET request to localhost. This span says that there was a database call. This is another database call. This span is an outgoing HTTP request. So a span is any arbitrary action in your application. And similarly, what you see here is like the two tiers are connected, the front end and the back end. And you see also the database calls and basically everything. I also showed you the log correlation, super important. I worked on it a lot, so I'm showing this to you. So you can go to like show trace logs, and what happens is that basically it pulls out the logs only for these requests. You see a little bit more here because I turned on debug logs, so like all the application entity framework call logs and .NET core logs. You see all that here, but if you search for, anyways. So basically, you have the log for the trace, and you can also go to the other way. So if you have only logs, then you can say, okay, show me the trace for these logs, and you can jump back to the trace. There we go. That's the trace, and you know exactly. Oh, this was interesting because in this trace we have an error, and you immediately know that two errors happened, and you can see that this was no such host is known. This was the failed outgoing HTTP request. This was when I did not have internet, and of course you also see the call stack. So these are two observability tools. So basically, that's the surface. That's what this is, and that's how it works. Any question to this? Yeah.
How complicated is it to enable this Elastic APM? Is it also just 2 lines of code?
Oh yeah. Yeah, awesome question. I wanted to show that. So how complicated is it to turn on Elastic APM? It's basically the same. So it's one NuGet package. Yeah, let me close what we already talked about. So Elastic APM, you can if you go to the GitHub repository, then that's behind the URL that I showed you at the beginning of the presentation. You see all this source code that I'm showing you here. And so yeah, basically all you do is that you add the Elastic APM netcore all package. And for log correlation, I added a couple of other packages, but basically there is a single line for turning on the Elastic APM telemetry collection. That's it. And for the log correlation, similarly to what I did in Application Insights, I added a couple of stuff for the log correlation. Basically, that's it. So yeah, that's a single line of code. Yeah, should be easy, and that's the goal. And for a standard scenario, it's easy. There was another question.
How is like if you want to run it in like containers? How does that then? I don't know. How do you get a correlation where you have problems in which containers, whatever?
Yeah. So if you have multiple, if your application runs in a container, it doesn't really make a difference. So the tiers are connected. So we saw on the UI that the two tiers are connected: the front end and the back end, the DB service and the front end. And the way this works, so this is basically distributed tracing. And I'm going to talk about what that is and how it works. And for distributed tracing to work, it doesn't really matter where your application runs. It can be two different physical machines. It can be two containers on two different machines. It can be two containers on the same machines. It doesn't really matter. So it will be connected.
But isn't it usually the case that you would want to also kind of know like in which container instances you may be having problems, or I don't know, like for that stuff? Do you get that info also in? Because usually if you're running inside a container, you don't get the info, that stuff right into your application. Yeah.
So you want to know where the container, so in which container it runs, and you get that data. So the agent also actually collects information about the container. So specifically, it collects the container ID. Okay. And that is sent here. I'm a bit confused because there we go. Okay, so you see, so we have, if you go to your transaction, you can see, so this wasn't running in a container, so there is no container ID. Yeah. But if this would have been running in a container, I should say one thing for .NET, so no, for general, so this is collected if it's a Linux container. Windows containers are a pain, that's very hard to get the container ID there, but who uses Windows containers, right? So no one, please don't say no one. Okay, yeah, so, but the container ID is collected. And then you could actually immediately jump to the, this is what I talked about, like correlating traces, metrics, and logs. You can, if you have Elastic also monitoring your container, you can jump to your container metrics, and you can get metrics for that particular container.
Okay. Yeah. Is it the same for application insights? Is it also built in?
Yeah, question is it same? I'm repeating for the recording, by the way. The question. So I'm not crazy, just okay. So the question is it the same for application insights? I don't know because I'm not working on that. I'm not sure. I need to look this up. I don't know if they collect container ID. Sorry. Yeah.
Can you also include logging and information from the client side, like Angular applications?
Yeah. Question: can you collect stuff from the client side, like Angular? Yes, that's another component. So there is a RAM agent which is basically monitoring your JavaScript and the whole front end and the browser, and that's another part that you have to put into your application. But yes, you can also monitor that, and that will be also correlated to the rest of the stuff. So we would have, so here we would have more for this request. Like we would also see what happens in the browser. Yeah, that's possible. I was too lazy to configure that. Yeah.
My question is about the minimum log level. So right now I think we are just logging every request.
Yeah.
And if I deploy it to production, production. Is that still the case, or do I increase the log level?
Yeah, so ideally you would not log. So question, what's the log level in production? What I did is terrible. I turned on debug log. I would not do that in production. So in production, I would just deploy it with normal log level, like error or warning. And if there is a problem, I would turn on debug.
And how would you do turning on the debug? Is it like a redeployment, or can you just change the log level in some configuration or environmental variable?
You could actually so actually you point out that my code is terrible. It's true. So I wouldn't really configure this here. I would actually do the configuration in the app settings.json, and if you change the app settings.json, then ASP.NET Core picks that up. So you don't need to redeploy. You just change the value here in the file, and then it will pick it up.
While running in production, I can just change the app settings.json.
Yeah, that's possible. Yeah. I'm sure, I think there are other better ways to do this, but that's one that I know about that works. Does anyone know any other options to change the? I think you have to physically go to that running instance, right? So it's I'm not sure if there is any other way. Maybe there are other logging tools that I don't know that lets you change it. But that's one thing so if you don't have code it like I did in the code, then you can change it through the settings.json. Yeah.
What about performance? Do these kind of frameworks have a significant performance impact?
Yeah. So performance is really hard to answer this question. The goal with this stuff is to be as don't be very intrusive. Don't put overhead to the application. It's hard to give you a number like that. Some companies say the overhead is 3%, but that's usually hard. It should be acceptable for production. That's definitely the goal, and it's already proven that this is the case.
But you still can turn off this on demand, right? Or is it?
Yeah. So some tools actually have options to just turn it on and off. I think application insights doesn't have it, and so the Elastic for .NET doesn't have that feature yet, but other agents, like for example for Java, we have that feature, or for Node.js, where you can just turn it on and off. And so that's definitely one approach that these tracing frameworks just can turn it off and turn on when you need it. That really helps for overhead, yes. Yep.
Maybe just a general remark on performance. So basically, if you take a look at the logging API, it's not synchronous. It doesn't have the asset principle. It's really and the basic idea is it has to be non-intrusive and fast. It has to be considered as not I/O, and at the implementation side of it all, they actually buffer inside.
Yeah.
So basically, you trace, and basically they have a buffer, and then really do the logging on a separate.
Yeah.
So basically, they do not influence that much.
Yeah.
Instead of execution.
Yeah. So the way this works is that when a trace is captured, for example, a database call, it's not like everything is stop the world and until it's sent. It's just we put that into the queue, and there is a background thread which patches the whole thing and sends that to the.
The impact on the execution or real execution of the thread is minimal.
Yeah. Any other question? Oh, okay. Let's continue. So. Let's talk about manual code instrumentation, because I showed you that lots of things are captured out of the box, but there are things that are not captured. And what can you do there? There is a thing called manual code instrumentation, and for this there are APIs. Application Insights, for example, offers this class called telemetry client. Telemetry client, you can track different things. You can track dependencies, events, exceptions, page view, request traces. And what you see here at the bottom of the slide, So what you see here is that we basically just direct an event, that's the prime number calculation, and then you can have a name for that event, and then you can pass arbitrary information with that. So here we, for example, we pass the return value, and this is going to show up in application insight. Similarly, Elastic APM also offers a public API. Let me use the laser pointer because that's better. Okay, so the Elastic APM offers we call this a public agent API, and with that you can manually capture anything. I told you that a span is any arbitrary action in your code, and here is how you can capture a span. So basically you just say agent.tracer.current transaction, that gives you the current transaction. You say on this transaction I wanna capture this span, which I call calculate prime. That's the type of the span. Then you have your code. It's just a comment here, but like that's the code that you really wanna capture. Like that represents the span. Let's say you calculate a prime number, right? That could be an example. And then if there is an exception, you can capture that on the span, and then you end the span. This API also measures you the time, so the time between this and this line will be measured, and you will see that automatically. Now you can say, well, that's a lot of code. It's ugly. I agree. There is another API which just gets a lambda for you. Like that you can put your code here that you want to measure, and this will start the span, end the span. So basically, it measures the time of this lambda. If there is an exception, then it will be also captured. So you can write this and you can manually end it. It can happen that the span spans across multiple methods. In that case, you have to end it manually. So there are cases where this is useful. But if that's just a single method, you can just do this. Let's take a look at this. So I talked about this. Yeah, we don't need that. Okay, so I showed you the code in the backend, and I showed you that there is a random number generated, and if that's, let's take a look at the application insights one first. So in the controller, we have this prime number calculation, right? So if the random number is 0, then we calculate this prime number, and we don't really have any information of that because that is not captured. Like this is a for loop, that's impossible to like just capture it by application insights. But what you can do is that you can use this telemetry client class, and with this you can basically just track the event. And with that, what happens is that if you go to application insights, let me show you how that will show up. So basically you can just look at all your events. Basically, we could also go from this performance stuff that I showed you before, but it's just easier to just hop here, and then that's where the calculate prime stuff is, and voila, we have the request. Here we see that this request took 4 seconds, which is a lot, and we immediately see that there is a calculate prime stuff. And what I also do there is that I save the number of prime numbers that were calculated, and also the biggest prime number, that's basically the last item in the list, and that also shows up here. Let's look at the same in. So basically, that's how you can extend the telemetry data. Let's also look at the same in Elastic. That's again, same code, it's just not telemetry client, the API is different. What we have here is that we basically just start the span, and when the prime number calculation is done, then we just end the span, and we also store the two data there, and basically that's it. Now let's take a look at how this works. For this, I don't yet have data, so I need to start this. Let me do this real time. And now I'm simply just generating data. Run. Let me just okay, application is starting. Remember that it doesn't always happen, so sometimes the random generation is not called. We just do this the prime calculation doesn't always happen. We have this random number, and based on the random number, we either calculate the prime number or not. I triggered a couple of requests. Let's look at what we see in Elastic APM for this. Okay, so that's the sample. Let's go to the front end. Front end sample 2, and what we see here is this is the distribution of the transaction, like the duration distribution. So we know that this transaction was super fast, right? So this was this was very fast. You see the millisecond value here. This was 482 milliseconds. And these were super slow. So if you look at one of the slow requests, there we go. We see the calculate prime number. That's the span that I captured manually with the code. And we actually also see that this took more than 4 seconds, like 4,438 milliseconds. So we immediately in the quick one, there is no calculate span. In the slow one, we see that most of the time is actually spent within this span. So that's what you can do with this, and then now the opportunities are endless. So you can place this into your code, and whatever is important to you, you can capture it and it will show up. Of course, I also added 2 additional data to this. It was the last prime, so that's the last prime number that was calculated, and we also captured the number of primes that this for loop calculated. So you can put any arbitrary information here and it will show up. The other thing is that it also shows you a call stack. So it actually shows you that this happens, in the database service controller, values controller, line 65. So you immediately know where this span that made the whole transaction slow happens. Okay. So that's about manual tracing. Any question to this? No question? Is it useful?
What I don't like that much is that you're introducing a dependency to the observability stack directly into your code. So I would assume I get an interface, like a logging interface, and just configure a sync where I want to send it.
Yeah, that's a really good point. So that introduces a dependency to this telemetry framework, and that's a problem for many people. And there is a framework to solve this problem called OpenTelemetry, which we are going to talk about. Okay. So yeah, this is not necessarily good that you just take a dependency on application insights or Elastic APM. It's good for my job security, but doesn't necessarily good for you. And yeah, people recognize this problem, and basically vendors that build these kinds of stuff came together and said, okay, let's build the stuff that is vendor independent and avoid vendor. It's not quite stable. We will talk about that, but I can already demo that to you.
But isn't this more like the case that you would usually use this thing if you were trying to figure out where you're having performance issues? So not that you have this stuff in general inside your code, but more when you're trying to diagnose.
Yeah,
because
but the more
in general you anyway have an overview of what's going on from this spans or whatever that something is going on, and then basically when you start to diagnose what you and research things, then maybe you would add it to your production code for a time being.
Yeah, but the thing is that the more you have from this within your code, the more you can see. So if something goes wrong, it's already good that if this is already in your code.
Yeah.
Yeah, but some people say that this is not an issue, so for them, yeah. Okay, so we have 7 minutes until the break. So either we continue with distributed tracing or we...
Let's continue. Let's see what we're doing when pizza's not.
Ah, pizza is not there. Okay,
Still
then,
not there.
then no pizza, rather distributed tracing. Okay. Yeah, so let's talk about distributed tracing. So I showed you that these tiers are connected, and I already started talking about stuff that when this runs in multiple containers, then it's also connected. And this whole thing is called distributed tracing. So if you have a monolithic application, then there is no issue, right? It's just one HTTP request it's served by a single process. Maybe it talks to a database, you can capture that, that's it. But this world is actually over. So what we have these days are infrastructures like this, where you have a front end, multiple services, multiple databases, and then when a user hits your website or application, it hits a front end, it talks to a service, it talks to another service, and then it talks to multiple services and a couple of databases. That's how real, like in a bigger multi-service environment, that's how the request is really served these days. And we actually have this in our tiny example in small with 2 services, with the front end and the DB service. Like in a real application, that's how it is. This is the architecture that we usually see, but what a tracing system shows you is basically that. This is how the distributed trace works. So we have the browser with the HTTP call, then we have our front end, then we have this fixer IO outgoing HTTP call to this currency service that gives me the currency exchange rate, and then there is the other span, which is the DB service, and that's how that's how these tools show this to you. And these things happen in multiple processes, right? So the part of this happens in the front end, part of this happens in the back end. This is the time, so basically the wideness of this box shows how long it took, and yeah, these are the spans. Now the way these are correlated is that every single span in this trace belongs to the same trace ID. Let's dive deeper how this works. So this is our stuff. That's the arrows show you the calls between the services. And let's redraw this a little bit, and let's show only the services that take part in this transaction. So we have the front end, and when a user, the following happens here. So when the user hits the front end, the tracing system is in the front end, and the tracing system asks basically one question: is already a trace ID generated for this trace or not? Given that this is the front end, it will generate the trace ID. And the front end calls the next service, and this is typically an HTTP call. Could be something different. We will talk about that. But this could be also, but typically this is an HTTP call. So what happens is that when the HTTP call happens, it adds something to the HTTP request, and it basically passes the trace ID to the second service. And then this is within the call that happens anyway between the two services. And then the second service asks the tracing tool in the second service asks the question again: is there already a trace ID generated? Answer is yes. So it won't generate a new one; it just passes it to the second one. So this goes like until the last service, and these basically share the same trace ID. And they can independently send this data to the tracing system. So the first one generates the trace ID, and during the calls, this is actually just passed to the next service. That's how it works. Now, like I said, the communication can be different. Like it can be HTTP, it can be binary, it can be a message queue, whatever. Let's focus on HTTP now. Turns out there is a standard called from W3C called trace context, and that solves exactly this problem. So the way the trace ID is propagated, that's defined in a standard. So what we see here, the two boxes are two services, and between the two services, then HTTP request happens. This is an HTTP GET, it has different parameters. If there is a tracing tool in these two services, the tracing tool does the following. It simply places an HTTP header into the HTTP request, And this header is called trace parent. And that trace parent contains the trace ID. So let's take a look at this trace parent a little bit in more detail. So that the trace parent is the header name, that's how it's called, that's defined in the standard. And then the value, the format of the value is also defined. Basically the first, you don't really need to know all the details, but basically the first part is the version, then the next part is the trace ID, then the next part is the parent span. So basically in the next service, you know what is the parent of that first span, that's stored there, and then you can store different flags, doesn't really matter. So this is made by W3C, and there are multiple companies behind that. So Microsoft, Google, and lots of like monitoring companies that have obviously interest in this. It's not like it's really close to being the official standard. It goes through a very complicated process where this is approved. It's basically very close to being approved as a standard, but this is a fairly new thing. And it has multiple features. So if you have, for example, a system where you use multiple tracing frameworks, it has another header where basically tracing systems can propagate information for each other. So you have three services, so A, B, C, and A and C are monitored by one tracing system, and B is by another one. Basically, what B can do is that it basically propagates all the data for the first tracing system, and it basically doesn't break the trace. That's what this is about. Yeah, let's skip this one. Okay, so let's take a look at how this works. So what I'm going to do here is that I will stop the backend, and we will just place a. No, let's go back to the site. So there is one new thing built into ASP.NET Core, which is that you can actually print this trace parent header. This trace parent header is part of this. Yeah, there we go. So this is part of the activity. There is an activity class which is for tracing. We will talk about that later. And you can, with activity.current.id, you can simply print the current trace parent header. What this activity is, we will talk about that in the second part. So with that, we do the following. We set a breakpoint in the backend when my machine starts working. There we go. Okay, so let's go with this one. Elastic. Okay, so when the request comes in, we do the following. Oh, we already do that. Okay, sorry. Yeah, so that's where we capture the activity ID. Like I said, this activity ID actually stores the value of this header. So let me just start it, and we will hit that breakpoint. Resolution makes everything bad. So actually it was already there. So the activity ID is this one, and as you see, that's the format itself is very, very similar to what I showed you on the slide. Let me just copy the value, and let me continue this. Okay, so with that the request is served, and let's jump into Elastic APM, and let's find this trace. So this is like something happened in our application, we want to see this. That's what this tool is for, right? So let's just jump into that. We can change the time frame. So I simply say show me the traces only for the last two minutes. With this we only see these traces. Sorry, yeah, anyways, let's go there. So we are in the backend. That's the DB service, not the front end. But what I can do here, so the front end is missing here. But there is a button here called View Full Trace, and with that I basically zoom out. So right now we are in the backend. Click that, and with that I also see the front end for it. Okay, so let's take a look at this, and it actually captures the HTTP headers. And there is a header called trace current. No? Isn't that? No? Okay, ignore that. We can do the following. The raw data is stored in Elasticsearch, and we can take a look at the raw data. So let's look at the document directly in Elasticsearch, and it will have a trace ID. Trust me. It has a trace ID, which is this. This is the ID that we captured in the backend, and it ends with PE and starts with, there we go. Now it matches. So it starts with A4 and it ends with PE. It's the same value. So what we see here, that's the trace ID in the front end, and we printed that with the debugger in the back end. That's how it works, and that's defined in this standard. Okay, so this is the distributed tracing, and this is how it works. Like I said, do we have pizza?
Yes, we can have a break whenever you want.
Okay, let's do one last demo, and then this is going to be like 3 minutes, and then after that we can do the break. So what I showed you right now is HTTP, but what about other protocols, right? So it's what if you just build a TCP socket and you wanna connect the two services? Well, there are two options. Either it works out of the box, that's HTTP and more protocols are supported, or there is actually an API for that. So, is it too small? We will take a look at this in Visual Studio. So basically there is an API that gives you this trace ID. You can serialize it as a string. So you can serialize it as a string in one service, and then you can transfer that string to the other service, and there is an API that lets you basically deserialize it and put that trace ID to the new transaction on the other part. So I prepared a very small sample application, which is a console application, and previously in our currency exchange stuff, HTTP was the transport protocol, but in this one, I'm going to be the transport protocol. So let's take a look at the code first. There we go. Let me close everything because this starts getting a lot. Okay, so this is a tiny console application. This does the following: that if there is zero argument to there is an if block. If there is no argument into this console application, all it does is that it starts a transaction. This is I showed you this public API that lets you manually capture stuff. That's the same that I used. And then I serialize the current distributed tracing data to a string, and we print that to the console. It will say the value of the distributed tracing data and prints the distributed tracing data to the console. And then waits 20 seconds, and then terminates. That's what it does. If there is one argument to the application, then what it does is that it tries to deserialize this argument as a distributed tracing data. As a professional programmer, no error handling here, so if that doesn't work, then it throws an exception. Who cares? But then it starts a transaction and passes this distributed tracing data to the transaction. It sleeps a little bit, and then ends the transaction. So we don't have it. Imagine that you have a batch process which is just started. It gives you an ID, and it just does some processing in the background during the evening or whatever. Like that's how those communicate, right? This is basically the same. So let me show you how this works. I'm going to open two command line prompts here. One short information here, which, oops, that's not the good one. There we go. The Elastic APM agent automatically picks up the name of the entry assembly in .NET as the service name. So this would be technically in the same service. So for that, I just set Elastic APM service name as, like, let's say service 1. And with that, and this is an environment variable, and if the agent sees this environment variable, then it will basically name this service 1 instead of picking the DLN. And I will name the second one, oops, wrong button. I will name the second one service 2. If you use Mac with Linux, it's not so easy. Okay, so let's call this service 2. Yeah, the set is missing. Let's call it service 2. And let me run that. So we run that without parameter. So in this case, it just prints the distributed tracing data. Let's just copy that. .NET run. Okay, now the second service is running, and it basically continues that trace. So basically, I am the transport protocol here. And if we look at this in Elastic APM, those should show up. Oh, service 1 is missing. Let me start it again. Oh, I know why. But anyways. There we go. Okay, so this is the second transaction, and we can click this view full trace, and as you can see, service 1 and service 2 are connected. So the two processes communicated through a command line parameter. We pass the trace ID, we use this API to deserialize the trace, and that's how you can do basically distributed tracing over any arbitrary protocol. Okay, that's it, and we can have pizza. Thank you.